Hi everybody, we are going to do a dihybrid cross. I want to show you how to do those. So basically a dihybrid, as the name suggests with the prefix di, is two different alleles and you're looking at the probabilities of them being inherited together. So basically, you have to know, you're given the name or the genotypes of the parents, and you have to figure out what the genotypes of the offspring will be. So we're going to use the alleles big G for green seed color, which is dominant, little g for yellow seed color, which is recessive, big R for round seeds, which is dominant, and little r for wrinkled, which is recessive. So we are going to just cross two parents who are heterozygous for both traits. Okay, so that's what both of our parents are going to look like. Now, when you are trying to figure out how or what possible gametes that an organism can have from a parent, with like a dihybrid cross, what you're going to do is you're going to use the FOIL method. Who remembers the FOIL method from algebra? You're going to do first, outer, inner, and last, and you're creating the gametes. So when we say first, we're talking about the first letter of each set. So we're talking about the G and the R. So this is a big G, little r. Outer means the outer two. So big G, little r. Inner means the two inner ones. So little g, big R. And last means the last two. So little g and little r. So those are the possible gametes for that parent. And since we are doing two parents that are the same, we don't have to do that twice. Okay, so I am going to draw our dihybrid cross Punnett squared. Now this one's going to be bigger than a normal monohybrid cross. You're going to do 4 by 4, and you're going to put your parents across the top again. But you're going to put the alleles that you figured out. So we figured out that they're, oops, let's turn that off. Big G, big R, all right? Big G, little r, little g, big R, little g, little r. And then because our parents are the same, we're going to do the same thing down the side as well. But obviously, if your parent was different, then you would put the other genotype there. Now, what I typically do is I go down and across to fill in my squares. So I'm going to take this and put it in each of the squares, and I'm going to put them on top of each other. So I'm going to do big G, little r, big G, big R, big G, big R, big G, big R. I'm going to do the same thing for this one. Big G, little r, big G, little r. And this guy. And this one. Now I'm going to go across. I'm going to start with this guy, big G. And then big G, little r, big G, little r. Imagine that's pretty boring watching somebody fill that out. Okay, so now we have the dihybrid cross all filled out, and you go back to your question. Every question is going to ask something slightly different. It may ask about the genotype. It may ask about the phenotype. Remember, the phenotype is what it actually physically appears like on the outside. The genotype is which alleles it has. So what are the letters? So if you can imagine, let's say, here, let me erase this for a second. Let's say we want to know the probability of getting a offspring that is dominant homozygous. So basically, out of 16, you're going to look for any that have two big G's and two big R's. And in this particular square, all you have is only one. So you only have one out of 16 1 in 16 chance of getting a dominant homozygous individual. Now, what about we say we want to know the probability of having a seed that is yellow and but round? Okay, so now you're looking for two different things. You're looking for yellow, which would be little g, and then you got to look for round, which would be either, because this is the dominant trait, big R, or big R, little r. Okay, so you can go about this a couple different ways, but you can go look for them one at a time. So say we're going to look for all the little g's and highlight those. Okay, so those are all the ones with the little g. But then of those ones with the little g, which ones are going to be round? So that would be this guy, and this guy. Okay, so this one here has is actually wrinkled, so he doesn't count anymore. So that leaves us with these 3 out of the 16 that are yellow and round. Okay, so it's really about getting the information in there, and then the analysis is pretty easy. Then you just got to step back and look at it and count your letters and see, which ones are dominant, which ones are recessive. Okay, hope this helps you figure out dihybrid crosses.